Hello everyone. Today let's solve the problem number 150. Evaluate reverse polish notation. Right. So here what is reverse polish notation basically? Here suppose we have 4 and the element 5. So we need to sum up this one means they will be given like this. Right. 4 plus 5, 4, 5 and plus. So reverse polish notation here in the sense if we need to sum up they will give like this. So here it will be 4 plus 5, it will lead to 9. If we need to subtract something, 5 minus 3, then they will be given like this. Then they will be given like this 5 3 minus. This will be basically 5 minus 3, that is nothing but 2. 2 is the output that we need to get. Basically, this is what the reverse polish notation is. So let's see what the question states here. Then let's try to solve the problem, right? So let's discuss the approach followed by the complexities and then let's write the code. Initially, let's see what the question states. We are given an array of strings. We are given an array of strings here. You can clearly see we have been given an array of strings here, right? Nothing but the tokens representing a valid reverse polish notation. Nothing but representing a valid reverse polish notation. Nothing but RPN. Again, I'm telling we are given an array of strings, nothing but the tokens representing a valid reverse polish notation, RPN expression. So what we need to do here, we need to evaluate the expression and return the result as an integer. Right, so we need to evaluate the expression. We need to evaluate expression means, yeah, basically accordingly with the reverse polish notation, right? So as we have discussed that one, basically I gave you two examples how it is evaluated. So we need to evaluate the expression and return the result as an integer. Operators are, so operators that they have given here is this one, plus nothing but the addition, subtraction, multiplication and division, right? Operations are nothing but we can perform addition, subtraction, multiplication and division, right? I hope this part is completely clear. Where division does not give the this one, division will truncate towards the zero, they have said. So division will not give any value. Basically it will truncate towards the zero, they have said, right, in the question. So each operand is either a number or another expression. Each operand that we consider is either a number or another expression. Expression is always valid, right? Expression is always valid and no division by zero. And they have strictly mentioned division truncates towards the zero, right? Division truncates towards the zero and expression is always valid and no division by zero. No division by zero. I hope this part is completely clear, man, right? I hope this part is completely clear. So let me delete this one. Question is very simple. Basically, let's come to the first example here. Let's come to the first example here. So 2 1 plus they have given here. In this case, 2 plus 1 we have to do, that will lead to 3. 3, then again we'll go with 3. 3 and 3 are left, then 3 into 3 we have to do. 3 into 3, because 3 3 multiplication symbol will be having 3 3 star, nothing but a 3 3 multiplication symbol, nothing but 3 into 3. Overall we have to get the output 9. This is fine. So same goes with this one as well. Same goes with second example as well. We have 4 13 5, this one 4 13 5. First what we will do, we'll go with the plus. So we'll go with the plus, right? 4 plus, so 13 by 5. 13 by 5, they have said that one division will lead to the, I mean, uh, yeah, where division truncates towards the 0, they have said. Division truncates towards the 0. So this one, instead of, we don't get this one in decimal, we'll get this one 2, right? 2 whole number. So this one will be 4 plus 2. We have to get 6 in this case. For the second example, I hope this part is completely clear as well. Let's come to the final example. Just give me a second here. Let's come to the third example. You can just have a look into it. You can just have a look into it. So here they have shown you step by step. You can just have a look into it. Basically, we have to apply the BODMAS rule. We have to apply the BODMAS. That's it. Nothing. So we'll get the output 22. The same thing, RPN rule and the BODMAS we have to. So here in this case, we'll get the output 22. So I hope the question part is completely clear. Just simple math, bro. Just simple math, to be frank. So we just should know what is RPN basically. What is RPN, and we just have to perform simple math. That's it. That's it. Let's go with the approach part. Let's go with the approach part basically. So first thing here is, let's consider this one. What do we call the first example here? So this one, let's consider this example here, the first example basically. Just give me a second here. 1 second. Yeah, we have the numbers 2, 1 plus and this one, operators plus 3, number 3, and finally the operator multiplication operator. This one I'm speaking. 2, 1 plus 3 multiplication operator. This one is fine. So here what we will do first, we will push 2. So first thing before discussing this one, we will be making use of the stacks. We'll be going with a stacks approach. We'll be going with a stacks approach again. I'm telling we'll be going with a stacks approach. Just remember this one, right? So I'll just write this one entirely stacks. This is fine. We'll be going with the stacks approach. So first thing what we'll do, we will push the first number is 2 here in this case, right? So we will push 2 to the stack. We will push 2 to the stack, right? Then we have 1. Then we have 1. We will push 1 to the stack. Now this 2 becomes 2 comma 1. After 2, what we did, we pushed 1. This became 2. 2 and 1 are in the stack currently. Now what we will do, we have the this one arithmetic operator. I mean, we have the addition operator here. Yeah, same thing, arithmetic operator or the addition operator here. So we have to perform the operation. We have to perform the operation here. In this case, what we will do, we will pop 2 and 1. We will pop 2 and 1 from the stacks. No, so now this will be, after popping, we will what we will evaluate. We'll evaluate. When we evaluate, we will go with 2 plus 1, nothing but 3. So this 3, what we will do, we will push this one to the stack. This 3, we will push this one to the stack. Now we have 3 in the stack. Let's go with the next number. We have 3. Now what we will do, we will push another 3 to the stack. Another 3 to the stack. So now this stack consists of 3 and 3. Stack consists of 3 and 3. Right now we have this operator. What do we call? Multiplication operator. What we will do, we will pop this one 3 and 3 from the stack and we will evaluate. So after popping, we have to evaluate. So we have multiplication operator, nothing but here we got 9. 3 into 3, nothing but 9. This is the output that we got total. So the output that we got here is 9, which is equivalent to the output that they have given for the example 1. Same goes with example 2 and same goes with the example 3. Only thing is we have to perform the BODMAS. Be careful, right? That's it. We have to perform the BODMAS. That's it. So 3 into 3 we got here as 9 finally, right? So first thing we pushed 2, then we had the element 1, we pushed 1, this became 2 1 in the stack. So to evaluate the expression, next we had addition operator. To evaluate the expression, we have to pop 2 and 1 from the stack and evaluate. So now we got 3, so we'll push 3 to the stack, right? So next element that we had is also the numerical value 3. So after pushing 3, we got 3 and 3 in the stack. Now we have to evaluate because we have the this one multiplication operator next. So to evaluate this expression, to evaluate this one, we will pop 3 and 3 from the stack and then evaluate the expression. This becomes 9. So this is how we got the output 9 basically, which is equivalent to the output that they have given for the first example. Right, so our approach works absolutely correct in this case. Our approach works absolutely correct in this case. I insist you to try out the same thing for the example 2 or the example 3, right? So that you understand the question clearly. So I insist you to try out for example 2 or example 3 so that you understand the things better, right? So I hope this one, whatever we discussed, the approach part is completely clear, right? By considering the first example. So now let's discuss the complexities very quickly before writing the code. So the time complexity would be quite obviously big of n. The time complexity would be big of n because we each token will be processed exactly once. Each token will be processed exactly once. Anything, each token here for this example will be processed exactly once. And the space complexity would be big of n as well. Why the space complexity here would be big of n? Because stack stores up to n by 2 intermediate numbers. We know this one. Just keep this in mind if you don't know. Stack always stores up to n by 2 intermediate numbers. Stacks always stores up to n by 2 intermediate numbers. So here the time complexity would be big of n and the space complexity would be big of n as well. These two I'm speaking of, right? So I hope the complexities part is completely clear. Yeah, complexities part is completely clear. Now, as we are completely familiar with the approach as well as the code, I mean approach as well as the complexities, let's start writing the code. Initially, what we will do, we'll go with the stack. We'll go with the standard stack here, just to store the operands and intermediate results, right? So let's do one thing. I'll just go with the just write stack here. So we are considering the integer, right? So integer. So variable name I'll just give stack here. Let's create new stack. So after creating the stack here, so what we'll do, we're just making use of the stack to store the operands and the intermediate results here. Let's go with the iteration part very quickly. For so this will be string token of tokens. This is fine. So within this for loop, so let's write the simple if condition here. So if we have the operator, nothing but if we have the token here in this case, right? So here let's go with simple if condition is operator. So then operator of token. So we need to consider token, right? So this is important basically. You shouldn't forget. So let's go with the second operand and the first operand. Right, so to evaluate we need to pop, right? So for evaluation we need to pop. So we are going with the second and first operand. So here I can just go in this way, I can write in this way. So here int b equals stack dot pop, this is fine. And here int a equals stack dot pop as well, this is fine. So after this what we'll do, we have to perform the operation, so we need to evaluate. So here in this case this will be result equals, let's make use of the evaluate. So here for making use of the evaluate here, we need to write the evaluate function. We need to write the evaluate function first, then we can just write the evaluate helper function, then we can make use of it here, right? So let's do one thing. Just give me a second here. For this one, here also, this one is operator of token, whatever I have written. To perform this one, this operation, basically we have to write the is operator function as well, right? So first, let's do one thing. Let's write the is operator and this one evaluate. So let me make use of evaluate here directly and let me write both actually. A comma B. So here this will be token. This is fine. So let me do one thing here. Let me come here. So did I forget something? So yeah, let me do one thing. Let's write the this one helper function is operator. So this will be boolean is operator of this one will be string token. This is fine. So within this function, let's return token dot equals of this one. We have to give all the operators right here. We are considering, we have to consider the operator. So what are the operators that are separate, I mean supported basically? So plus minus this one multiplication operator and the division operator, right? Addition first, let's go with the addition here. Where is addition operator, man? So here this is fine. Or so let me copy paste the same thing and make the necessary changes here. So here let me paste the same thing. Or so let me come to the next line so that this looks good. So here let me paste the something same thing, and again or let me paste the same thing here. So this is fine. So here let's change the operators. Plus minus divide. So here I'll just give multiplication operator. This is fine. So this is it for the is operator. This is it for the is operator function. So here this is fine. So let me come out of this one entirely. Let me come out of this one entirely. Now let's write the helper function evaluate. So I'll just go with private int evaluate. Within the evaluate, so let's pass the parameters a, b, and also string operator. This is fine, and also string operator. So within this, within the evaluate function, so let's make use of the switch here. Let's make use of the switch. Let's pass the operator here. So first step, let's go with the case. We are going with the switch case right here. So this is fine. So let me give what plus operator we are making use of right here. So this performs this one addition. So I'll just go with return a plus b. Return a plus b. It's been ages that I have made use of the switch case actually, to be frank. So let me copy this one, paste, paste, paste. So let's make the necessary changes quickly. Before this one, let me write here, we have to return 0. Means we should never reach here because due to the valid input constraint here. So let me give here in this case return 0. This is fine. So let's make the necessary changes quickly. This will be minus, this will be multiplication operator, and this will be division operator. So this will be a minus b, a into b, and this will be a by b, right? So this is fine. So, and one more thing, we know this one, we have discussed this one, division always truncates towards the 0. They have strictly mentioned in the question. Just keep this in mind. So don't forget this. So this is fine. We have already made use of the is operator here, and also we are making use of the evaluate function as well. Evaluate and the is operator helper function we are making use of. Right. So I hope this part is clear. Next we are um, left with, after performing the operation within the main function, what we need to do, we have to push the result back to the stack. For pushing the result, stack provides the operation push, right? So I'll just make use of stack dot push of result. So this is fine. I hope this is fine. So else what we will do, else what we will do, so we have to push the number to the stack. So this will be stack dot push again. So this will be, we have to push the number to the stack, right? So this will be integer dot parse int of, so we have to pass the token here, as we have to pass the number to the stack. So this is fine. So we are done with almost everything. So we are left with only one thing, that we need to return the final result that will be on the top of the stack, right? So let's go with return stack dot pop. So this is fine, stack dot pop here. So let me format the code once we are done with the code. So this is it for the code. Let me hit the run button. So here I hope this works for all the test cases, man. So what happened? Yeah, hey, 25 and 26 we have illegal start of expression. What illegal thing I have done here? What illegal thing I have done here? Switch off operator, this is fine. Case, this is fine, right? Oh, this one we have to give here, right? Just 1 second. So let me, so here colon we have to give here after the operator, right? After operator within the strings. So here this has to be this one. This is fine. So let me format the code once and let me hit the run button. Line number 30, semicolon expected. Where? Oh, this one. Okay, 30. So let me hit the run button again. Now this has to work. Again, one more error. Is operator of token. So this has to be capital O. Line number 6. So we have made use of the is operator. O, capital O, capital O. So yeah. So again, let me hit the run button. So yeah, now you can clearly see the sample test cases are getting passed. Means the code works absolutely correct in this case. Let me hit the submit button. Let's see whether this works for all the test cases. I hope this works. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case. Yeah, For now, I hope the solution part is completely clear, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.